All right, so we're computing limits again. This time what we have is, I'm going to suspect with some experience that this limit doesn't exist, and this is the meanest scenario, or what you can expect on an exam for when you're doing basic introductory limits is absolute value should always be a caution, and we know that absolute value bothers you as a function, and then we put it in a limit, and we don't give you a one-sided limit approaching from above or below. So what you have to think in your mind is this absolute value guy going to behave the same if I approach -1 from both values? And probably not, because absolute value is defined as a positive thing or a negative thing depending on whether the expression on the inside is positive or negative. So first of all, people don't look at or analyze what this means. That's a function, and we're looking at what's going to happen to this function near -1. So what is this function? So first of all, let's just look at the absolute value of x plus 1. Nobody likes this, but the definition is whatever's on the inside is itself if x plus 1 is positive or non-negative. And it's the negative of that, x plus 1, if x plus 1 is less than 0. So I can rewrite that one more time. This is x plus 1. It's itself x plus 1 if x is greater than or equal to -1. It's equal to its negative x plus 1 if x is, I'm just solving these little inequalities, if x is strictly less than -1. So now I can see that this is where, with experience and if you're comfortable with absolute value, I know that this function is probably not going to approach the same value when I approach from above or below, because I can see that the top part of it is a different function in both. Let's build the function. What that's saying is, you want to get rid of the absolute values. This is how we're going to get rid of the absolute values for that function. So now what I'm going to do is, what is this if f of x is the absolute value of x plus 1 over x plus 1, what is that? That's actually, by looking at this definition, which I'm erasing, this is equal to x plus 1 over x plus 1, which is 1, if x is greater than or equal to -1. So it's just a constant function, 1. And this will equal x plus 1 over negative x plus 1, which will equal -1 if x is strictly less than -1. And then this is why we start showing you in the early sections of this introductory chapter on functions why I want to sketch the graph of this, because it gives me an intuitive idea, and the geometric avatar of this scenario is going to show me really easy that the limit doesn't exist. I can't use that as a proof, but it will give me a guide definitely. So let's build the geometric avatar of this. At -1 we're switching, so if you're less than 1 or -1 and not equal, you're just the function -1, just the constant function -1. When I reach -1, I become the function 1. So this is f of x equals the absolute value of x plus 1 over x plus 1. It's just a constant function. Because it's a constant function, I see geometrically or pictorially already from its geometric avatar that clearly the left hand limit is approaching 1, or sorry, the limit from above, or the right hand limit is approaching 1 as I approach -1 from above, and it's approaching -1 from below, so the limit doesn't exist. There's a jump discontinuity, we're going to call it later. So how do I algebraically show that? I'm still going to use this again to get rid of it in the limit, but what you have to do now is, once we've analyzed that and thought about the absolute value, you want to approach from above and below and see what happens, and show that the left hand limit doesn't equal the right hand limit, therefore if and only if the limit doesn't exist. So this limit isn't going to exist, and how are we going to argue that? We're going to argue by computing the left hand limit and the right hand limit. The left hand limit. The limit as x approaches -1 from below of the absolute value of x plus 1 over x plus 1 equals the limit as x approaches -1 from below. And this is what bothers you, and this is why my side calculation on your exam or on your assignment, don't erase that. That was the calculation that justifies how do I, the student wants to get rid of the absolute values. How do I do that? I pre-analyzed. So as I approach -1 from below, I know my function is just equal to negative x plus 1 over x plus 1, because I already analyzed. And that will equal the limit as x approaches -1 from below. There's a lot of negatives going on. These cancel and I get -1. So this is just -1. It's a constant function. So the left hand limit is -1. The right hand limit is the limit as x approaches -1 from above of the absolute value of x plus 1 over x plus 1. And now I want to do the limit as x approaches -1 from above, and I want the absolute values to go away. If x plus 1 is larger than 1, which it is, -1, then I know that this will become x plus 1 over x plus 1, which is the limit. Yes, you have to write that every time. Stop skipping it. -1 from above of 1, which is the number 1. So what we're seeing is the left-hand limit doesn't equal the right-hand limit. Therefore, the limit doesn't exist. I can write that out. The left-hand limit is equal to -1, which does not equal 1, which was equal to the right-hand limit. Therefore, the limit as x approaches -1 of the absolute value of x plus 1 over x plus 1 does not exist. Thus, let's try that again. Come out of the pen. Thus, wizards gotta use their wizardry sometimes.
Pure magic.